Assalamu alaikum everyone. Welcome back to science class. I'm Ms. Amara Imran Malik and today's lesson is one of the most important topics in all of the chemistry, that is covalent structure. Now I want to ask you something. Have you ever wondered why diamond, which is made up of carbon, is the hardest natural material on the earth? And at the same time, nitrogen gas, which is also made up of non-metal atoms with covalent bond. These non-metal atoms like nitrogen gas floats freely in the air and can be cooled to minus 210 degrees Celsius before it even becomes a liquid. They both involve atoms joined by covalent bond, yet one is an incredibly hard, which is carbon, and almost unmeltable solid. And the other is very light, invisible gas. Why? The answer is all about structure, how the atoms are arranged and connected. And that is exactly what today's lesson is about. By the end of the lesson, you will completely understand the difference between simple molecules and giant covalent structures. And you will be ready to answer these questions in your Cambridge exams as well. Here are our 5 learning objectives for today. First, you will understand what a covalent bond is and how it forms between atoms. Second, you will compare simple molecules with giant covalent structures and know the key difference between them. Third, you will explain why diamond and silicon dioxide have very high melting points. Fourth, you will also explain why nitrogen and sulfur dioxide have very low melting points. Fifthly, you will practice these reading data from a table and then you will be able to draw scientific conclusions just like a real scientist. These are exactly the skills that you are looking for. So let's tick every single one of these boxes today. What is covalent bond? So before we can understand structures, we need to understand the bond itself. What is a covalent bond? A covalent bond is a bond formed when two atoms share a pair of electrons. But why do atoms share? Here is the reason. Every atom wants a full outer shell of electrons. A full outer shell makes an atom stable and happy. If an atom doesn't have a full outer shell, it will try its best to get one. When two atoms come close together, they can share their electrons. This way, both of these atoms can count those shared electrons as their own. Both atoms now feel like they have a full outer shell. And that sharing creates a very strong attachment between them. That is known as a covalent bond. Let's look at the simplest example, that is hydrogen gas. It's H2. Each hydrogen atom has just one electron but needs two for its full outer shell. So two hydrogen atoms come together and share their electrons. Both can now count two electrons. Both feel stable. And that bond between them is one covalent bond, or you can say is a single covalent bond. What the important thing that you have to remember, covalent bonds mainly form between non-metal atoms like both carbon and nitrogen. They are non-metal elements, so they form covalent bonds. Now let's meet two elements today. These are carbon and nitrogen. Both are nonmetals. Both form covalent bonds, but they are incredibly different from each other. Carbon has 6 electrons in total. Its outer shell has 4 electrons and it needs 4 more for a full outer shell. That means carbon will form 4 covalent bonds with other atoms. At room temperature, one form of carbon is diamond, that is sparkly, extremely hard solid, while nitrogen has 7 electrons and its outer shell has 5 electrons and it needs 3 more. So, nitrogen forms 3 covalent bonds, but at room temperature, nitrogen is an invisible colorless gas, that is N2. In fact, about 78% of the air you are breathing right now is nitrogen. And this is the same idea between covalent bonds but completely different results. Both of them are having the same idea. Both are having with covalent bonds, but they are very different from each other. One is hard solid and the other is a gas. The reason lies entirely in how the atoms are arranged over there in their structure. And that's what our next slides will explain. Let's start with the simple molecules using nitrogen as our main example. A simple molecule is a small group of atoms held together by strong covalent bonds inside the molecule. Nitrogen exists as N2, two nitrogen atoms joined by triple covalent bond. That means 3 pairs of electrons are shared between the 2 nitrogen atoms. This triple bond inside the molecule is extremely strong. Now, here is the crucial question. If the bond inside N2 is so strong, why does nitrogen have such a low melting point, that is of about minus 210 degrees Celsius? The answer is about what happens between the molecules. While the bond inside each N2 molecule is very strong, the forces between N2 molecules, the force that is present between each nitrogen molecule is very weak. That is why they are present in a gaseous state. Imagine a room full of couples and each couple holds each other very tightly. That's the strong covalent bond inside the molecule. But when they pass other couples in the room, they only give a small knot. That's the weak force between molecules. Now you can imagine this thing. When we melt nitrogen, we are not breaking those strong bond that is present inside the N2 molecule. We are only separating the molecules from each other. And because those between molecules, the forces, these forces which are present between molecules, these are very weak. Even a tiny amount of heat is enough to do it. So, they are able to convert that nitrogen into a gaseous state. So, it's low energy needed. Its melting point is very low, that is minus 210 degrees Celsius. And other simple molecules like also oxygen, which is O2, methane, CH4, carbon monoxide, CO, and sulfur dioxide, SO2, work exactly the same way. The weak molecular forces between molecules. So, when there is weak molecular forces, they are having a low melting point. Now, let's move to complete opposite giant structure, giant covalent structures. So, a giant covalent structure is a 3-dimensional network of atoms. All of these atoms joined together by strong covalent bonds. There are so small separate molecules here. It's one enormous continuous structure that extends in all directions. A diamond is the perfect and most famous example from your daily life. In diamond, every single carbon atom is bonded to 4 other carbon atoms by strong covalent bonds. And those 4 carbon atoms are each bounded to another 4 and so on. In all directions, they are just spreading over there. And the pattern repeats millions of times over. That is why there is a strong intermolecular forces over there, like the force which is present between molecules. This creates a massive, rigid, 3-dimensional cage-like structure where every atom is firmly locked in its specific place. Now think what happens when you try to melt diamond. To melt it, you need to separate the carbon atoms from each other. But every single of those atoms is held by 4 strong covalent bonds. Now you need to break all of those millions of bonds which are present between different carbon atoms. And breaking all of those bonds requires enormous amount of heat. That's why the diamond's melting point is 3550 degrees Celsius. That is hotter than the surface of the sun. And that is also why diamond is the hardest natural substance on the earth. Those covalent bonds hold every atom so tightly that nothing can scratch it even. Now the turn is silicon dioxide. Diamond is not the only giant covalent structure. Another excellent example is like silicon dioxide, which is known as SiO2. You know silicon dioxide very well. It is the main component of sand and quartz crystals. And silicon dioxide has a giant covalent structure very similar to the diamond. Silicon atoms and oxygen atoms are joined together by strong covalent bonds in a repeating three-dimensional pattern. The pattern extends in all directions, just like the pattern was present in the diamond. And to melt silicon dioxide, you must break all of those strong covalent bonds which are present throughout its structure, and this requires a huge amount of energy, which is very high. That is why its melting point is also very high. It's about 1710 degrees Celsius. This also explains a fun everyday fact as well. The sand on the beach doesn't melt in the hot summer, even when it feels scorching. That's because the sun does not produce nearly enough heat to reach 1710 degrees Celsius. Look at the mini table on this slide. Nitrogen at minus 210 degrees Celsius, while silicon dioxide at minus 72 degrees Celsius have low melting points. They are simple molecules. Silicon dioxide at 1710 degrees Celsius and diamond at 3550 degrees Celsius, both of them are having high melting points. So, nitrogen and sulfur dioxide are having low melting points, while silicon dioxide and diamond are having high melting points. Why? Because they are having a giant covalent structures in their pattern. Now we are going to compare simple molecules versus giant structures. This comparison table brings everything together. Let's go through it row by row. First, we are talking about size of structure. Simple molecules are small, just a few atoms are over there, and giant covalent structures are huge, containing millions of atoms all connected with each other. Next is the types of bonds or the strength of bond present inside. Both have strong covalent bonds inside, and this is the same. Do not confuse yourself, because both of them are having strong covalent bond within their molecules. Like if we are talking about simple molecules, for example H2, so there is a strong covalent bond between two atoms of hydrogen within the molecule. We are not talking about intermolecular forces. Forces between units. Now simple molecules have very weak forces between them, while giant structures have none, because there is no separate units. Everything is one connected structure. Now what does it mean? Like if we are talking about H2, a hydrogen element, as an element, when we are talking about hydrogen, so all the hydrogen atoms are connected with each other to make the hydrogen molecule by H2. So there is no you can say force of attraction between every molecules of hydrogen with each other. There is no force of attraction between molecules of hydrogen, but there is a force of attraction between atoms of hydrogen to make it a molecule. While if we talk about the giant structures, so there is a strong force of attraction between different, like if we are talking about diamond, yes, silicon dioxide, so there is a strong force of attraction between all carbon atoms, which are making a huge structure over there, because there are no separate units. Everything is connected in one single structure. Next is its melting point. So simple molecules are having low melting point, while giant structures are having high melting points. Energy to melt. Simple molecules need a small amount of energy, while giant structures need an enormous amount of energy to melt, like their melting point is very high. In which state they are present at the room temperature. Simple molecules are often gaseous or liquids, while giant covalent structures are always very hard, solid. If we talk about their different examples, like in simple molecules, there is example of carbon monoxide, sulfur dioxide, oxygen gas, and nitrogen gas. While for giant structure, there are two examples like diamond and silicon dioxide. Next, I want to make sure that this concept is completely clear because it's the favorite exam topic as well. So, melting means separating particles from each other. The harder it is to separate them, the more energy, the more heat they needed. More energy needed means higher melting point. For simple molecules like nitrogen, the N2 molecules are floating around with only weak forces between them. You can see. So imagine gentle magnets like that barely attract each other. Even a small push of heat easily separates the molecules from each other. Very little energy, very low melting point. For diamond, every carbon atom is locked into the giant network by 4 strong covalent bonds. Imagine trying to remove one brick from a wall where every brick is cemented to 4 other bricks in every direction, you can say. So you would need an enormous force. This same thing is applies here. Breaking all of those bonds needs enormous energy, so their melting point is very high. The key question to ask yourself is what exactly am I breaking when this substance melts? For simple molecules, you are only separating the molecules, overcoming the weak forces. While for giant covalent structures, you are breaking millions of strong covalent bonds throughout the entire structures. So, thinking scientifically, how you people are able to make conclusions from the data given. Scientists don't just learn facts, they use data to draw conclusions. This is called thinking and working scientifically. And it is an important part of your Cambridge course as well. In your textbook, a student named Ikra is studying 4 covalently bonded substances. She cannot measure melting points herself, so she does not have the substances or the right equipment. So she does what any good scientist would do. She finds the data in a reliable secondary source, a data book. So the data she finds over there is carbon monoxide at minus 205 degrees Celsius, diamond melts at 3550 degrees Celsius, silicon dioxide melting point is 1710 degrees Celsius, while sulfur dioxide is minus 72 degrees Celsius melting point. So from this data, Ikra draws a conclusion. I want to try to draw your own conclusion before reading hers. So which substance are simple molecules according to you? Think for a while, and which are the giant covalent structure? Think about what we just learned about melting points, the substances with low melting point, which are mentioned over there like sulfur dioxide or the carbon monoxide, must be the simple molecules. Only weak forces between their molecule is present, which is needed to be overcome. And the substance with high melting points like diamond and silicon dioxide have giant covalent structures, so they need a huge amount of energy to break all the covalent bonds. This is exactly how scientists think. Observe the data, use scientific knowledge, draw a logical conclusion, and you are able to find out the exact answer. So which key points you just have to memorize it, or you have to remember. They are 5 in number. These are the 5 golden points, you can say. Number 1, a covalent bond forms when 2 non-metal atoms share a pair of electrons. Number 2 is simple molecules have strong covalent bonds inside, but only weak forces between the molecules. So this gives them the low melting point. Number 3, giant covalent structures are 3D networks where all atoms are joined by strong covalent bonds throughout the entire structure. Number 4, giant covalent structures have very high melting points because breaking all those bonds needs enormous amount of heat, needs a lot of heat. Number 5, examples, diamond and silicon dioxide are giant covalent structures, while nitrogen, oxygen, carbon monoxide, sulfur dioxide, these are the example for simple molecules. These 5 points cover everything you people will have to learn for this topic. Now it is the turn to show that what you have learned. Different questions given over there on the slides. Number 1 asks you to write the definition of giant covalent structure, and this is you people will have to learn by heart. You just simply learn the definition for giant covalent structure. In the next question, that is question number 2, asks you to name 2 substances with giant covalent structure. So it's very easy. We have discussed it for many times during this lecture as well. The next is you have to ask you to name the type of bond in both simple molecules and giant covalent structures. Think carefully, is it different for each? Like for simple and for giant covalent structure, is it different or not? In 3b, they are asking you to explain why atoms form covalent bonds. Why atoms form covalent bond? It's very easy. I'm just giving you the specific answer for the next, but let's try by yourself that are you able to answer it or not. Question number 4 is the most important one, and in this they are saying just explain why simple molecules have lower melting point and giant covalent structure are having higher melting point. It's very important question. Now you just have to pause the video now and try to write your answer by yourself. You can take your time like 8 to 10 minutes, but try to write it in the correct form. Yes, for welcome back. Let's mark your answer. Have you done it right or wrong? Question number 1, write the definition for giant covalent structure. So there are, it's can be of 2 marks. Number 1. Mark number 1 comes from just saying a 3-dimensional network of atoms, and the second mark you people are able to get that they are joined together by covalent bonds. So what will be your answer? A giant covalent structure is the 3-dimensional network of atoms that are all joined together by strong covalent bonds. So you will have to learn this definition as well word by word. Question number 2 is name 2 substances which are covalently bonded. So very easy. These are diamond and silicon dioxide. So common mistake writing just carbon instead of diamond. So you just have to write it its complete name, that is diamond, because diamond has a giant covalent structure. And diamond is correct, while if you are just talking about carbon or carbon elements, so graphite is also correct. It's another form of carbon with a giant structure. Silicon dioxide, quartz and sands are all correct for the second mark that you can earn by writing. Next is name the type of bond. Which type of bond is present? So the answer is covalent bond. You can just write it by one word, but notice that the bond type is the same for both simple molecules and giant covalent structures. Both contain covalent bonds. The difference between them is not the type of bond. It is the size and extension, or you can say it's the size and extent of the structure. So sometimes students sometimes say like giant covalent structure has stronger bonds, but this is incorrect. The bonds are covalent bonds in both cases, in simple molecules as well as in the giant covalent structures. For question number 3b, explain why atoms form covalent bonds. Atoms share electrons so that each atom can achieve a full outer shell of electrons and become stable. You have to write both of these things to earn your 100% marks. If you are just saying atoms share electrons, so without explaining why, you would only get 1 mark. So always include the reason with your answer as well. Question number 4 is the big question number 4. Explain why simple molecules have a lower melting point than the giant covalent structure. So in substances with simple molecules, the forces between the molecules are very weak. Only a small amount of energy is needed to overcome these weak uh, forces present between molecules. While in giant covalent structures, many strong covalent bonds must be broken throughout the structure, which requires a large amount of energy. So the melting point is much higher. Now, the most important thing that there must not be the mistake. So there is one mistake that student make every time. They say the bonds inside the molecules are weak. This is wrong. The bonds inside the molecule are very strong, but the forces between the molecules that are very weak. If you make this mistake, you will be unable to get the marks. So inside, you just have to remember this thing: the forces present inside the molecule, they are very strong covalent bonds, but the forces present between molecules, they are having a weak forces. Now, that's a wrap on today's lesson on covalent structures. You have done an amazing job working through some quite complex chemistry concepts. Let's do our final recap. Covalent bonds form when non-metal atoms share electrons to achieve a full outer shell. Next thing we have learned, like simple molecules have strong covalent bonds inside but only weak forces between molecules that will uh, leading them towards the low melting point. Giant covalent structures are enormous 3D network of atoms, you can say, and all of these atoms are bonded together by strong covalent bonds, which lead them towards a very high melting points. Next is a diamond melts at 3550 degrees Celsius and silicon dioxide at 1710 degrees Celsius. They are having the giant structures, while nitrogen, sulfur dioxide, their melting point is very low. You just have to practice writing definition of giant covalent structures to memorize it. Then you will also be very well focused on question number 4, that is the very main concept. Okay students, with this we are just coming towards an end of the lecture. So I'm very proud of each and every one of you. Keep working hard and try to learn and memorize all these things. Have a blessed day. Allah Hafiz.